What you've got in front of you here are two questions which are asking you the same thing, but they're actually giving you slightly different information. So looking at the first one here, let's have a look at the question first of all and interpret the maths that we need to use to actually solve it. Well, here's the clue. First of all, it's a geometric series and you're looking for the sum. So you would go straight into your formula booklet and you would start looking up the formulas for the sum of a geometric series. Now, you've actually got a choice of two formulas. There's one that looks like this, and there's another one which is almost the same, but these things are switched around. Now, in the formula booklet, it'll actually give you some guidelines about which one to pick. But the bottom line is you're going for the one that's going to avoid you having a negative number in your denominator. So you're going to use this first version here when your common ratio is less than 1, because that's going to give you a positive answer in the denominator. Here, you're going to use that one when r is greater than 1, and then you're going to get a positive answer in the denominator. Now, you can never have a ratio of 1. There's no geometric series that can have that, because obviously if you substitute it into your formula, you end up dividing by 0, which is impossible. So that's why there's nothing for r equal to 1 here. Now, it's a question of choosing these two and then getting your answers. So if we look at the first one there, what you've now identified is which formula that certainly you've got two formulas that you could use. So what we're going to do is we're going to actually look at the other information we're given. So what information can we take from the question? Well, we know that it's got 10 terms, so we know that n equals 10. So what you should be doing is you should be taking the information, and let's just change the colour there, looking at the information and thinking, what does that fill in my formula? Well, that means I'm going to know what the n is in both of those formulas. So I've got my first piece of information. So you can see the second thing that's missing that I need to know. I need to know the ratio, and I also need to know the first term. Well, the first term's easy. We can actually see it in the list of numbers. So we've already know that information as well. So we've got almost all the information we need to put into the formula, and you can see the only information that's missing is what is the value of r that we're going to substitute into these formulas. Well, you've already been getting the common ratio in other problems, so I can take any two numbers that go together. Let's just take the first two, because that makes it nice and easy. Make sure the one that comes second goes on the top, divided by the one that came before it. Oh, it wasn't 5. I'm thinking too far ahead. There's my common ratio. So I've got all the information I need now to simply substitute into one of these formulas. And I need to decide which one it is. Well, look, here the number's bigger than 1, so I'm actually going to go for this formula here. If I do 5 minus 1 in my denominator, it's going to give me a positive answer. So for my final answer then, I can say, right, the sum up to 10 terms is going to be the first value, which was 7. So I'm substituting directly into this formula here with all my different values. I've got my common ratio of 5 raised to the power 7 minus 1, close the brackets, all divided by, now I can just do that in my head. The common ratio is 5, 5 minus 1 is 4. So to get your final answer, you could, because you get 5 to the power 7, if that came up, so I would have to really just do that in a calculator. Let's pull up my GDC, here it is here. So I'm just going to save time here, I'm just going to enter it in directly. 7 times, open my brackets, 5 to the power 7, come down, minus 1. So I've got all of that, and finally divide by 4. I don't need to worry about the brackets on the numerator because that's all going to work out quite nicely. Get the answer. You get a big number like that, 136717. Now this is an exact number, it's an exact answer, so in your exams you wouldn't round that number off. So that then is the answer for the sum in that particular question. So it's just a basic list of numbers and you know the number of terms, and you just have to choose which of the formulas you're going to use. So let's look at question 2. Question 2 is similar, but when you're tackling question 2, you need to really think about the information that's missing. So at first glance it looks like the same, so I would read through the sentence, Here's the bit that tells me what I've got to do. I've got to find the sum of a geometric series. So let's start off the way we started before. I'm going to write down my formula. But I've got two formulas to choose from, and so I look at the common ratio. Here the common ratio is a negative. So that means that when you go to your formula booklet, you've got to choose the one that's going to give you a sort of positive number in the denominator, and that's going to be this one, the one where it's switched around. So that's what I'm going to use. So far so good. Right, well, what information do I need? I need to know the first term. Here it is here. They might say that in words or they might say it in symbols, so I know what U1 is. So here I'm just going to put my working in. So this one here, U1, is replaced by 8, so I've got 8 times, and everything's looking good so far. I'm just sort of building this up so that I can just substitute in the things that I'm missing. So then I say, okay, great, now all I need is my common ratio. And then you go up to that question and you say, oh hey, wait a minute, you don't tell me what the common ratio is. Let's just take away that first one so we can focus clearly on this second one. So this is an example where you've got a question buried inside a question, because really it's easy to use the formula, but it's actually finding this value that's the key. So what you'll be doing at the moment is you'll be looking at that question and be thinking, wait a minute, how am I supposed to, where am I going to get R from? Well, if you think about it, they don't tell you things for nothing. If they tell you this, it must be relevant. There must be something to do with that. And this actually comes back to what you were doing in your previous exercises. This would be, you've got a geometric series and you know what the last term is, so use that to find out the value of, say, n, how many terms you've got, something like that. So if I come through this, if I know the last term is 52488, what I could say is, I know that this number in here, which is the last number, 52488, must equal, and I can substitute things in here, so it's going to equal the first number, which was 8, multiplied by, oh, I still don't know that common ratio, and I still don't know how many terms I've got. Did they tell me at all there? Oh, yeah, well, wait, no, they do tell me the common ratio. Take that back. I know what the common ratio is. So actually, the missing piece of information now is actually n. It's not r. We actually know what r is. They give us r in the question. R is -3. So actually, if I come back to what I was doing earlier, if I substitute -3 into the r positions, I'm going to have to be careful here. That's going to be -3 in a bracket, raised to some power of n that I don't know yet. And I'm going to have 1 minus 3 on the... 1 minus... Oh, I'm getting stuck here. I'm doing things in my head. 1 minus -3 is 1 plus 3, which is 4. Okay, there we go. So I've now put that common ratio information in. Now over on this side, this thing that I was working on looks like that. And what you've actually got now is an exponential equation. We can solve that in the same way that we solve other ones without using logarithms. I can simply enter this into my GDC using the table method. So I'll pull up my GDC, I go to this one, type that in as a formula. It's 8 times, now I have to be careful with that negative. -3, close my brackets, raise to the power, and I can now just type in, basically it's x for your calculator, which is the same as n. So you can see I've just typed it in exactly as it appears on that side. Second function table. Now I should be able to scroll down that table if I've done it properly and find the number 52488. There it is there. 52488. So it's the 9th term. So what I know from using my GDC n equals, and I'm actually just writing that for the examiner, so the examiner knows how I got my answer. I'm saying, well, I put it into my table, I got n is equal to 9, so I actually know how many terms I've got now, and I can then come back to the original thing that I was filling in, and remember I didn't know what the value of n was. Well, I've now worked it out, so I can come back to that formula, put it into the power n position, so it's the power 9, and that has to be closed. And again, I'm going to put that into my GDC and get the answer. I'm not going to be expecting you to do minus 3 to the power 9 in a paper 1 without a calculator. So I could simply come back here and say, right, enter all that into my GDC. Let's just get it up into my GDC here. Clear. Second function quit. Clear that. 8. Okay, now I'm going to have to be careful with my brackets here because I'm going to do a calculation in the numerator and then divide it by the denominator. So I'm going to put everything in brackets. 8 times bracket. And again, more brackets coming in here because I'm dealing with a negative number. The ratio, common ratio is negative 3, so I've got it inside brackets there. I'm raising it to the power 9. And now I can come out of that power and then I'm going to close that bracket. That's so what I've actually done here, let's check it, I've done 8 times all of that number there, and then I've got to close the bracket again. Now, if you think that looks confusing, let me just show you. These red brackets here just group the whole denominator into one place. So that's why I've got extra brackets in there, and then I'm simply going to divide that answer by 4. So press divide by 4. Let's just hope we get an answer that makes sense. It's a nice, solid, whole number answer, and usually when that happens, you can maybe sit back and think, well, 39368. I haven't got any odd numbers, so the chances are it's right. Not always true, but sometimes it is. So that's how you do it. That's how you handle a question like that. So just to recap, what you're basically doing is you're starting off with the formula, you're going back to the question, and you're basically ticking off the things that they tell you. I missed that a while ago that they've given me the common ratio. So I can substitute the ratio in, I can substitute in the first value. This was an example where you didn't know the value of n, so you look at the other information you're given. It's a question within a question. So we had to come down here and use an earlier technique to find that value of 9.